Yeah, I wanted to kind of share with you. Now it's starting to get kind of winter time here. I think our high temperature yesterday was 29 degrees, and I think I had 10 degrees this morning. But I'm out in my shop out here, and this has only been heated the last few weeks with these solar collectors here. I took a picture of this building. This is my shop, um, and this picture is about a year old. We just got the photovoltaic system on top. It's a 7.8 kilowatt system out here, and I was sharing this with some friends. And I took a picture of this on a very cloudy, dreary day. But what I'm here to talk about today are these collectors on the outside. There's four here in the newer versions, and I've built these five here over probably the last 20, 25 years. And this one here is fairly new. That's why it still has a little bit darker color here too. Um, and these things do a marvelous job for heating my shop I'm in here too. Now this shop is 52 foot by 36 with 9.5 foot ceilings. So if you can look around here, there's never enough room. I always need more room, but that's what I built many years ago here too. So, and I've really divided the shop up in two sides. This is kind of my cold side or dirty side over here. I have a Maslow CNC and I do my machining and my welding over in this side. It's a little cooler because you can't see it here, but there is garage door on that side that doesn't feel always the best. And the inside over in this side, this is where the wood burning stove's at then too. So it's a little bit warmer then too. But still, these things, well, yesterday I think when I was taking pictures here too, it was 67 degrees in here, and that's just from the solar. And that's both sides. It was just really nice. So how I did this too, I'm going to talk about these things too, that this is the version one. Okay. Again, I started building these things 20 some years ago. What this one is, it's actually a 2x4, but metal 2x4s. Okay. And I put foam on the inside of the metal 2x4s, and even though there's some horizontal beams here, also metal 2x4s, they've been filled with holes and Swiss cheese, and it's hard to tell. I'll show you a clearer picture, but there's an intake down here and all sorts of baffles to kind of change the airflow, and then the outputs at the top up here too. It's real similar to my version 2, okay, but my version 2 has a little bit different airflow, which actually they both do an excellent job. But I think the version 2 does a better job at night at maintaining the heat. Okay, so his here version 1 again, and I'm going to tell you right now, my version 1, I use GE silicone 2, wonderful stuff, many years ago, and used that for the Lexan or the polycarbonate. I think it's called twin wall, might be the trade name, but this stuff is still fastened 20 some years of all that heating and expansion. Even the side beams here, the horizontal pieces, are still adhered to. Yes, there's a lot of yellowing going on. There are some actually holes and where I've got some damage to these things. They do get fragile. There's enough UV exposure. They do break down then too. This is the last newest one. I figured, well, I got another section to go here, so I added one of these things. This is probably 4, maybe 5 years old. But what you can see here, if you look carefully in the picture here, I got cracks, lots of cracks. Um, Mostly where the GE silicone 2 is in contact with it. And I was trying to figure this out because this is odd. And then I found out that the silicone 2 has been reformulated. And so it used to be appropriate for polycarbonate, but maybe it's no longer appropriate for polycarbonate. So if you do make something like this, there are some sites out there that talk about appropriate polycarbonate adhesives into you, but gee, silicone 2 is not. I will have to redo this in a few years here too, but I'm just going to let it it still works fine. It's not leaking, but it's not the best either here too. So this is the main difference between these version 1 and version 2. My earlier ones have this intake right here in the bottom, okay? And there's a filter system on the inside, basically on the floor, and that cold air comes in here. There's all sorts of baffles going back and forth, and then it exits the top. Okay, over here in the bottom, this is one of these exiting places. I have a little a flap of just some, I think this is bubble wrap on top. So when it kind of tries to draw back down at night, that flap will, it will cover that and prevent it, or actually, I should say, maybe decrease how much the air will flow backwards into. Whereas in my new version, both my intake and output are at the top. So, and I can put my hand right on this and feel it's cooler than this side over here when it's actually functioning. So intake here again baffles to make it sort of go all over, and trying to get all the heat I possibly can out of it here too. And here's a picture over here of both the air filter, which is really a nice benefit of both these systems. Not only do they heat the shop, but I have 9 air filters filtering my air here too. But anyway, this is the intake, and this is the output, another muffin fan basically, that I use just to push it out here. And again, you got to be I found you need to kind of match your fan to the heat you have. My brother-in-law had 2 different systems he purchased. One of them had a squirrel cage that would just scream. It's just like, yeah, you had wonderful output of air, but it never allowed enough heat transfer, I think, and I thought that system never really worked very well. And these muffin fans really do a nice job. My output will be anywhere from, depending on how sunny it is, but I've seen 140 some degrees, and I don't want to go a whole lot higher than that. I'll probably start outgassing some of my paint then too, even though this is high temperature flat black paint. But yeah, these things do a nice job. They're not too obnoxious in the sound. Um, but yeah, they're I really like how these things work then too. So these are AC muffin fans. I'll talk about how I control them a little bit later then too. So, but this is the main difference between the two. When the sun goes down, now the cold air, of course, is denser. It's going to try to fall down to the bottom, and even though that flap on the top will kind of flap back here. In fact, this is what I use. I use these little caps here. And I just cut a hole on here, and I put that flap, and it'll kind of hold back on here. It will limit how much air comes in the top, but I can put my hand right down here in the bottom here and feel cold air coming out. Because yeah, it's trying this thermal siphon, and there's a big enough area there so the air will exchange, and I get this cold air rushing out. Whereas in my new versions here, because there is no output in the bottom, okay, or any hole in the bottom, the cold air just sort of stagnates in the bottom, and I don't get that thermal siphoning. And I think this is much better. I noticed this side over here just seems to stay better, and I like this how I've routed the air here, so to speak, then too. So, but yeah, that's the main difference between the two. So now this is made out of 2x4s and plywood. The other one was all steel 2x4s and from drywall construction basically. And how I did this, I just put three 2x4s. I mounted that on the side of my shop out here, built this frame in the shop, and there are a couple blocks in the back of these things here too. And had a buddy came over. We just heaved the whole thing on top there and made sure that the block was sitting on the 2x4, and then screwed it in place. And it was nice and level, and had no problem here too. And even though I got some gaps here on the side, well, what I did, I took some of that flashing, aluminum flashing, and it's easy to cut. It's in snips, and I just kind of use this as a template in the back here, mark the places, and cut them off and caulk them, so it really seals up quite nice. And I do have a little break, so actually, even though I got wood here, it's all encased in aluminum. Now this aluminum, you want to use a real thin aluminum if you possibly can. If you start putting a lot of mass in here, well, that's a lot more mass to be heated up then you do not get to extract that heat off of there. If you make this as thin as possible, well, there's more heat available then too. So this is why I use aluminum. It helps transfer the heat real easily. So if there is one spot that gets hotter because I'm not getting airflow, well, that will still transfer off someplace else and get picked up then too. So I have the plywood back, gives a lot of stability. I have the holes marked here, and I foam them. And I cut the holes in all the way through the shop as well. They're a little bit cut larger than this, the pipe I use for the metal heating pipe then too. I foam the outside. That just seals the whole area up, and then I will just use the kind of like a keyhole saw to cut them out, so my pipe will still fit through there. And what this is just 1 inch a polystyrene I like this aluminum on the outside because hopefully it will reflect heat back then too. And then I basically use this aluminum flashing. I think it's like 32-inch like wide rolls I get, and they are all pop riveted together. The flashing put on here with the baffles. And then I finally mount these windows here. Now the windows I got from a quite a deal. I was at work one day at school, and I kept hearing crashing, glass breaking, and they were redoing a dorm next door and tearing it down and basically throwing these windows away. In fact, if anybody's seen my greenhouse video, these are the windows I used to the greenhouse. But these things weren't the best. They didn't open the best, and so I just took off the hardware, sealed them so they could not open, and used that as basically as my glazing then too. So yeah, they were, I think, $2.50 a piece. I got them on real good deals. I think I mounted, took home a couple truckloads of these things stacked up pretty good then too. But yeah, I like the glass, even though it's single pane. Heats up well. If you put more layers of glass, yes, you get more insulation. However, you also decrease a little bit of your solar coming through. So yeah, you kind of, you know, got to kind of balance what you got here too. So anyway, that's how I built these things, and there's some more in the process here too, the baffles and too. And again, I'm just ran out of paint here too, but I use a high temperature, like a grill paint, flat black and two. These are all actually the conduits are mounted on here too. So, but and then basically this is the starting trips I use. Again, I'll just pop ribbon to the top right here too. So, but anyway, this is the input and output here too. These are the vents I use or the filters I use. This is the old style filters, and that's the new heaters I use for the basically the muffin fan did too. And this is a video I have on how easy these are to switch. There is screen in the back, which is really important. And basically just a magnetic latch at the top, so it makes it real easy to switch. And here's one in action here too. And yeah, you see the little spots there, and there's a box elder bug right there. That's why you have to have this screen on both your input and output. Otherwise, you're making a nice winter home for all these bugs to live in and go die then too. So yeah, you have to make sure that everything is covered with screen. Otherwise, you're in there and you'll never get them out until you rebuild these things then too. Now, for this particular thing, I just used some more aluminum flashing. I cut the hole out, folded over the edges, a little more stability. And when I folded them over, I just folded in some of the screen here, which I put a couple dabs of silicone to hold it in place in too. They've been working real well. It does not interfere that much with the airflow. And this is just aluminized mylar. I clip them on here too. That seems to hold up really well for years. So I kind of like that. So okay, let's go back in this side here. Oops. Then this is my controller. Okay, now this is the old controller down here. And again, I'm talking old technology. I used a basic stamp 2. That's what I was into back in those days here too, and it works perfectly fine. And this is the new version. But again, I already had all the artwork for this printed circuit board right here done. And so I just went ahead and I had all the parts. So I did another basic stamp 2, even though it's a technology I have not really been using for a while when I built this. But what this is, there's two sensors here. One sensor is the inside, tells me what the inside temperature is. And this day when I took this picture, it was 29 degrees outside, and it got down pretty cold the night before. But the inside and the cold side of the shop was 48. The solar was producing 114 degrees. The high temperature so far was 139. And my low temperature for the season, or since it's been reset, was 40 degrees. Now, this D is delta. Because I have two temperature sensors, okay, I can actually measure the temperature of the shop and also to measure the temperature of the greenhouse. And that's really important because my first system just had a little trigger. If it got up to a certain temperature in the solar collector, it would turn on. Well, it may have been, say the temperature was 60 or 70 degrees or whatever here too. It may be warmer inside and I was pumping cold air back in. So yeah, you need a smart controller. And one of the benefits about the smart controller I found out is that it seems like it gleans more of the heat So I mean, I don't know if you can hear it, but right now it's starting. It's thermal cycling. It's cycling on the other side over here, and what that does is basically the temperature drops inside that delta, not enough to trigger it. Okay, and so it'll turn on for a couple seconds and the temperature drops down. And what it does, it turns the fan off and heat builds back up again and it turns back on again. So really it still produces a pretty good usable temperature heat, but it just kind of has to build up and pump it in, build up and pump it in. So yeah, it does an excellent job at gleaning the heat then too. So but again, I'm not posting the artwork or the code for this just because this is older technology. And boy, I really like the Arduinos and all the libraries come with that. However, if you've seen my greenhouse video, okay, my greenhouse video uses Arduino Uno, and it has the same components. It has the LCD, solid state relay control, and temperature sensors. And so if you go into that particular and look at that on GitHub, look at that repository, you can actually download the artwork and the code and everything if you want to build one of these things in too. They're not that hard. Um, I have a video out there too on how to do a printed circuit board. And again, that kind of scares some people here too. But you know, I heard something the other day about investments. In fact, they say the very best investment to do is in yourself. And so if you have to learn how to do a printed circuit board, those skills, or learn how to program, hey, that's a wonderful investment in yourself. It'll have wonderful dividends here too. So anyway, that's what I got so far about this solar collector. I've been wanting to do this for a while because it just works so well. And there's nothing like coming home or coming out in the shop here too. And this place just takes care of itself. Yeah, I still will have the wood burning stove when it gets 30 below, like last year, a couple of days here too. Or if it's a cloudy day, I'll have a wood burning stove going. But it's really nice just use the sun's heat to heat this place, and it will just automatically take care of it and filter the air. So anyway, hope this helps. If anyone wants to give this a try and they're running into problems, you know, drop me a line or something. You know, I can always sort of point you in the right direction here too. So, well, anyway, I really enjoyed these. So I hope you do too. Have a good day.